Hi there. Today we are going to discuss a moment of a force. We will go over moment, direction. We will also discuss couple moment and go over some example problems and provide you with the practice problems. Moment of a force by definition is, again, it's a vector quantity. It has a magnitude and the direction. So magnitude of the moment of a force is defined as force times the perpendicular distance or the shortest distance. So for example, if you're applying force the way it is shown here, so if this force is applied, it will try to rotate about point O. So it will try to rotate like this. So that would be the rotation that would happen at point O. So this moment that is causing that rotation would be defined as force times the perpendicular distance or the shortest distance from the application line of application. So this is the line of application. Shortest distance is going to be D. However, if you incline your hand by certain angle, say theta, then what happens? The force time distance, again, distance from line of action, this is the line of action, is going to be this, which is d sine theta. Considering this 90 degree, this angle is theta. So this length is going to be d sine theta. So force times d sine theta would be the magnitude of this force, which is at angle theta. And if you apply force like this, now the line of action of this force is actually passing through O, meaning the shortest distance from the line of action to the point O is actually 0. So there would be no moment. So moment is going to be equal to 0. Now this is how, again, finding out the strength of the moment is actually force times the shortest distance. The direction of the moment is defined using a right-hand rule. So right-hand rule meaning if you try to mimic the rotation that is going to happen due to the force about the point that you're interested in through your fingers. So fingers are kind of telling you the rotation that is going to happen. And then depending upon the direction of the thumb, if it is pointing upward, it's a positive. If it points downward, it's going to be a negative. You can also follow the clock to mimic the similar information. For example, if your rotation follows the counterclockwise about the point, then it's going to be a positive moment. So again, counterclockwise, if you take this right hand and put in front of the clock, this is what you will see. So if it is a counterclockwise rotation, then your thumb is pointing outward, it's going to be a positive moment. Whereas if you do clockwise, then it's going to be a negative moment. Moment can be expressed, it's a vector quantity, it can be expressed as a vector r cross f. R is the position vector of force f, and the force f is the force vector. So if you take the cross product of these two vectors, you're going to get a vector which is going to be perpendicular in the plane that would be perpendicular to r and f, and that would be the vector moment. So if you have a multiple forces acting, then we can use the Varignon's theorem and we can add the individual moments of each forces and find out the total moment that would act in the system at that particular point. When finding out the moment, it's really important to note the point about what point you're trying to find the moment, because the tendency to rotate is going to be different about different points. So whenever we are trying to find out a moment, the first thing we need to know about what point. In this case, that point, the point of interest that we have is point A. So we are trying to find the moment about point A. So to find the moment, what we have to do, we will take the forces and we will find the shortest distance from the point A. The easiest way to do that would be decomposing these forces into components. Then we will have the perpendicular distance would be much easier to compute. So force F1 is 375. It's acting 8 feet away. That's perpendicular distance or shortest distance, 8 feet. 8 feet is the distance from the line of action of force. Now for the other forces, let's decompose them into the components. So F2 force, we can decompose them in horizontal and vertical forces. So based upon the information that we are given here, we immediately know 500 3/5 is going to act in the horizontal direction. It will act along this side and it will act at the same point. Remember, whenever you take the components, make sure the point of application remains same. So again, these horizontal and vertical forces, they are applied at the same point where the F2 was applied. So horizontal component is going to be 500 times 3/5. Vertical component is going to be 500 4/5. And they will be again 400 and 300 pounds respectively. Now let's look at the other force, F3. The horizontal component would be like this, and vertical component would be like this, and this would be 160 cos 30, this would be 160 sin 30. So once we found all the forces, now we can write the moment. To write the moment, we need to worry about the magnitude and the direction. Magnitude would be force times the perpendicular distance or the shortest distance from the line of action. And then we will also be careful with the direction that it is trying to rotate. The first force that we have, 375 pounds. So this force about point A, this is our point of interest, it's going to rotate like this. So this would be the rotation that it would cause about point A. So this rotation, as you can see, it's a clockwise, or if you use right hand rule, your thumb is going to point downwards. So it's a negative moment. Same thing with 400 pounds. It's trying to do the same effect about point A. It's a negative moment. And this force is also doing the same thing. So it's also going to be a negative moment. So all the vertical forces we have already accounted for. So if we write the moments, the 400 times 14 would be the moment due to that force. And 138.56 times this distance, which is 19, would be that moment. And it's a negative moment. Now, horizontal forces, let's go one by one. So this horizontal force, this is passing through the point A. So shortest distance is actually 0. So 300 pound is not going to cause any rotation about point A. But 80 pound force that we have here, it's not passing through the point A. It's actually away. So if you are at point A, this force will try to rotate like this. So this would be the rotation that is going to cause, right? So remember, rotation is counterclockwise, or if you use your right hand, what you see, your thumb is pointing upwards. It's a positive movement. So it's a positive movement. And if you put everything in calculator, you get 11,192.64 or negative 11.192 kip feet. Now let's move on to the couple moment. So couple moment comes into play when there are couple forces meaning equal and opposite forces acting on a system. For example, if you take example of a steering wheel, if you apply 30 Newton and 30 Newton with both hands in the opposite direction, then end result would be this thing will rotate. In fact, if it is a steering wheel, that's what you really want to do. So if you apply a couple, all you will get is a rotation. There's no motion required here. All we need is the rotation, not translation, but the rotation. So 30 times 0.4 will give you the amount of the moment that we have in this case. Same thing, if you reduce the distance between the forces, then what would happen if you wanted to get exact same rotation as you got here, then you have to increase the force. So again, you need to apply higher, stronger force to get the same amount of rotation. Same thing, if you move your hand outwards, then you have to apply less force to get the same amount of rotation. So couple moment comes into play when there are two couple forces acting, meaning same magnitude but the opposite direction. We need to have two forces which are acting in the opposite direction and they're non-parallel. They are going to result into a pure moment. There would be no resultant force, meaning because the forces are equal and opposite, they're going to cancel each other. So all you will have is the pure moment in the system. And that moment, the pure moment that you will have is simply force times the distance between the forces. Remember, the distance here is the distance between two forces that we have. And this is a free couple, meaning any point in the system, you will get exact same moment. So it doesn't really matter about what point. That moment is going to remain same with any point that we have in the system. So as long as it's a force times the distance, and distance being the distance between those two couple forces. Let's do a quick example here. So we have 150 pound, F equals 150 pound, and then we have another 200 pound force. So these are the two set of couple forces that are acting, 150 pound couple and 200 pound. Our goal is to find the resultant couple moment on the rod. Now, to find the couple moment, what we could do, this couple is kind of known, it's 200 times 1.5. But this couple, to get the perpendicular distance between these two forces or the distance between these parallel forces, either we can compute this distance or it would be much easier if we can decompose them into horizontal and vertical forces. For example, the horizontal vertical forces for these two forces are going to be something like this. And since we know the slopes, if it is 150, vertical is going to be 3/5 of 150, which is 90. And horizontal force is going to be 4/5 of 150, which is going to be 120. So these are actually the forces. Now, What we have is we have a couple forces, 90 and 90. Then we have 120 and 120, 200 and 200. And these are the only forces these are the only forces that are acting on the system. We have no other force. So the resulting couple moment would be due to these three couples. So first couple is 90 and 90. The magnitude is going to be 90 times 4. So 90 and the distance between them is 4. So 90 times 4. It's a positive couple because if you look at the rotation, these 90 and 90, they will try to rotate the system like this, right? So they are trying to cause the rotation like this. So this rotation would be counterclockwise, or if you use the right hand rule, your thumb is going to point upward. So it's a positive moment. If you look at 120 forces that we have, their rotation is also counterclockwise. Again, this is how they're going to rotate, right? They will rotate like this. It's again counterclockwise motion. It's a positive moment as well. And the third force that we have 200, if you look at them, they will rotate clockwise. Again, their rotation is opposite. So it's a negative moment, 200 times 1.5. Again, if you use right hand rule, your thumb is going to point downward in this case. So it's a negative moment. And if you add everything together, you get 240 pound-feet. We have some practice problems for you. The first question, we need to find out the moment about point B. Again, point of interest is point B. And the second problem, we have two couple forces acting, and we need to find out the couple moment. I hope you found this useful. See you next time.